The broadcast is now starting. All attendees are in listen-only mode.
Good morning. I'm Kyle Smith. Welcome to our Enertech webinar series, and today we're going to be with Jeff Hammond, and I am the Inside Sales Manager here at Enertech. So on the next slide, we'll be going over today's session. So we're actually doing another three-part series, and we're working on something that we requested from Jeff that we're seeing as a very popular subject, and that's two or more pumping scenarios, flow centers, on large residential or light commercial systems. So that's what we'll be going over today, and the challenges associated with multiple unit applications, multiple flow centers versus a central pumping system, and then system efficiencies, advantages, and disadvantages. Now, the next webinar, we're actually going to be sending out with an announcement on it, so it will not be part of this series. However, you just need to sign up for that one as well, that you'll be receiving later today, and a thank you from attending from us. But in the second webinar, we'll be doing the multi-unit applications with Geo-Flo's MP multi-flow center design. That'll be on August 10th. So we'll be doing a flow center overview, operation, options, features, benefits. Then the next webinar will be a much larger option with multi-unit applications and the additional to the NP multi-flow center. So that'll be continued on that for August 17th. And then we'll be going on to the additional options that could be done with that MP multi. If you have any questions, though, please contact our inside sales team. Today, please take notes. Ask questions. You can actually use the tool there on the right-hand side of your screen in the GoToWebinar toolbox and type them in there, and we'll be able to answer those at the end. And then lastly, research and review. After the webinar is over today, please feel free to contact us or the Geo-Flo website for more information. And with that, Jeff, I'll hand it over to you.
All right, thank you, Kyle. I appreciate everybody's attendance this morning. At the end of the session, we'll be taking questions. So if you want to type those in on your screen, then we'll take a look at those. So today, as Kyle mentioned, we're going to be talking about multi-unit applications. We see this a lot for large residential, light commercial systems, and sometimes it presents a challenge. So we're going to look at possible solutions. Well, starting off, we'll start simple here: a single heat pump with a single flow center, single ground loop. As you can see in the picture, it's relatively easy installation, and it's also very efficient, especially if you go with a variable speed flow center and a two-stage Enertech heat pump. Now we have the capability of dialing in the flow based on the compressor stage. Either a pressurized or non-pressurized system works well, and it's a good way to go. Of course, that's that's sort of self-explanatory. When we get into multiple units, that changes things a little bit. So when we have two heat pumps, one approach is using one flow center for two heat pumps. It's still a pretty good way to go. It's not as efficient as a single unit, single flow center, single ground loop, because we have a bit of a compromise on flow rates. In this application, we have to set up a flow rate for unit 1 and a flow rate for unit 2, so we can't take as much of advantage of that two-stage compressor. There's some additional wiring, relays, and so forth, and additional piping and tees. Same thing here, it's pressurized or non-pressurized, same advantages from an efficiency standpoint. So not quite as easy as the first one, not quite as efficient. Now if we go with a flow center for each heat pump, and this is on a common loop, it's a little bit more energy efficient. It's like having our original scenario, although we do have parallel operation, so it's not quite as efficient as a single unit, single flow center, single ground loop, but it's still pretty good. It is a little bit more cost. Now we have the price of two flow centers instead of just one. And one thing we do have to watch for, this is fine on a pressurized system, but we cannot install two non-pressurized flow centers on the same loop. we'll have the possibility of a tank overflowing. So you can really only use 2 flow centers if they're pressurized on a common loop. All right, now this is an application that's relatively new. The dual circuit flow center is really the easiest way to go when you have 2 heat pumps. This has piping to each of the heat pumps, as well as built-in check valves, T's, foam insulated tank. And so just like you see in the picture here, we have connections to the heat pumps, connections to the ground loop, and all of the rest of the piping is inside that flow center. This is also an efficient way to go because we have 1 pump or 2 pumps, depending upon the size of the system, for each heat pump. And so we are able to control flow rates and pump watts based upon whether heat pump 1 or 2 is in first stage, second stage, both are running, and so forth. So this is a great solution for 2 heat pumps. When we get into 3 or more heat pumps, things become a little trickier. It's not nearly as easy, and efficiency depends upon your choices. So are we going to choose a single flow center, multiple flow centers, 1 common loop for all of the heat pumps, or multiple loops? Will it be constant or variable speed pumps? Will we have a mix of single and 2-stage heat pumps, and so forth? So a lot of questions to answer on multiple units, and that's really what we want to concentrate on this webinar. So the first one is common or individual loops, and that'll depend on a lot of things we'll talk about here shortly. A central pump or a pump for each heat pump, that involves some redundancy. If a central pump goes down, the entire system is down. Now, if you have electric heat, you do have emergency heat in the wintertime, but in cooling, there will be no cooling, of course, if our central pump goes down. Pump selection is important. Central pump, if it's constant speed, can be problematic if only 1 heat pump's running, especially if it's a small heat pump. We might have as many pump watts as heat pump watts. The other issue with that type of situation, if we have multiple parallel flow centers, we might not be able to attain proper flow rate if all the heat pumps are running. So pump selection is pretty important. Loop pressurization, air elimination, flushing and purging, all those become more important as we get a larger system, simply because we have a lot more pipe in the ground, and the flexibility of HDPE pipe can present some challenges. Also, there's some limitation on piping sizes. Most fusion kits that are available are up to 2 inches. Of course, there are larger tools available, but they're a lot more expensive. And we're limited to about 36 gallons per minute with 2-inch pipe, so 12 to 15 tons. Header piping, same thing. We want to make sure that we don't have a system that's not flushable with a standard Enertech flush cart. So all these are some challenges we need to look at. The guidelines that I use to look at helping answer those questions. First off, we have to consider your capability, if you're the loop installer, or your subcontractor's capability. Is 2-inch limitation, or can we go to 3-inch pipe if needed? Should we go to multiple 2-inch supply and return lines, and so forth? So that's something that is pretty important too. The limitation as far as piping goes. Another limitation could be the flush cart. Most residential flush carts are designed for 10 to 12 3/4-inch circuits. So if we're looking at 1-inch circuits, if we're looking at 1.25-inch circuits, we have more than 10 or 12. We have to be a little bit cautious there. There is a calculator on Geo-Flo's website that will determine whether or not you can flush that loop with the Enertech flush cart. And the C here, fortunately, is not an issue with Enertech, since Enertech has an inside support department, inside sales. This is a big deal. Pump control, selection, all that kind of thing. So Enertech can help you with that. Are the heat pumps single speed or 2-stage? A 2-stage heat pump benefits more from a variable speed pump, of course. Does the customer want redundancy? We have to look at that on a central system. How far apart are the heat pumps? If we have 1 heat pump at one end of the building and 2 at the other end, it probably doesn't make sense to combine those 3 on a single loop, just because of the amount of piping. But if they're all in the same mechanical room, that's a little bit easier to justify a common loop. And that leads into number 5. Will sharing that loop help maintain a milder loop temperature? Most residential applications, it doesn't make a lot of difference whether you have a single loop for each heat pump or you have multiple heat pumps on the same loop. Now, in a commercial building, that's completely different. In a lot of cases, you can have heat pumps and heating and cooling at the same time, and so you're just sharing heat around the building, and that does make a difference, but it's rare on a residential application that you would have heat pumps in heating and cooling at the same time. And lastly, we have to look at it from a financial standpoint. What's happening in the market? Does it make sense to go this route? All right, so that's a little bit of an overview of some of the challenges we have. We'll start with a distributed system, and this is multiple flow centers in the same loop. So we have a flow center for each heat pump, and all those flow centers are connected to the common ground loop. All right, so some advantages: no central pump is needed. That's certainly an advantage. The flow centers are easily controlled. When the heat pump turns on, the flow center turns on. It does have built-in redundancy. If one pump fails or one heat pump fails, the others are still available to run. The disadvantage is, in almost every case, the pumping watts are substantially higher when you have all these pumps in parallel. There are two reasons. Number one is you just have a lot of pumps, but secondly, parallel pumping allows you to have higher flow rates, but the same head of one flow center or one pump, depending upon how many pumps are on each flow center. And it's sometimes difficult to figure out loop pressurization. Where do you place the expansion tank? What do you do about air separation? Are the flushing valves in the flow center adequate, or are there larger flushing valves needed? And as I mentioned earlier, we can't put multiple non-pressurized flow centers on the same loop. So some challenges with distributed systems. Did an example so we can at least compare some different systems. This example is a 12-ton system, a 3, 4, and 5-ton heat pump in the same mechanical room. So we have two packaged units in one split system. Fairly standard loop piping and header, propylene glycol antifreeze. And I used rule of thumb for the pump sizing. I don't like rule of thumb, but for this example, I thought it would be a good starting point so we can see what sometimes rule of thumb does to our designs. All right, so we'll start off. This picture shows a graph of the system curve with only the 3-ton system running, and I used rule of thumb, one pump for this 3-ton unit. It happens to be a 2699 Grundfos circulator. And you can see here where the system curve crosses the pump curve, we get about 10.5 gallons per minute. The system needs 9, so we're in fine shape if only the 3-ton heat pump is running. All right, when the 4-ton unit is running, same thing. I use my rule of thumb, two 2699s, a 2-pump flow center. And where the system curve crosses the pump curve, we have 14 gallons a minute, a little bit more, and the heat pump needs 12. So again, no problems. Now the 5-ton system, same thing. It's when it's running, it has more than the flow needed. It needs 15 gallons a minute, and we can attain 16. So no problem if each of the heat pumps are running independently. Now let's start to look at some different combinations. I now have a 3-ton system running, that's the red curve, and a 4-ton system, that's the blue curve. So with my rule of thumb pump selections, I can get about 8.7 gallons per minute for the 3-ton. It needs somewhere between 7 and 9, so I'm in fine shape. On the 4-ton, my 2-pump selection gives me 12.5, and I need 12, so again, I'm in fine shape if the 3 and the 4-ton unit are running. All right, now we have a lot more arrows and graphs and dots, so I apologize for all the confusion here on the page, but you can see what happens here when we have all 3 heat pumps running. My rule of thumb selection on this gray line is a 1-pump flow center. The red system curve is the 3-ton unit. I can attain 6.8 gallons per minute, and the minimum flow rate required by the Enertech catalog is 7. So I'm a little shy. If I go to a 26116 pump, I can get just slightly over the minimum requirement, and that's a 2-pump, by the way. On this 4-ton curve, that's the blue line, my rule of thumb here gives me 9.5 gallons per minute, which is just barely above minimum. I could go to the 116 pumps, Grundfos 26116, and I could get above minimum a little bit more. The 5-ton unit, same story. If I'm running with our rule of thumb selection, I'm actually below the minimum required of 12 gallons per minute, so I have to upsize the pumps. All right, so what happened? Well, it's a combination of how we've placed these pumps. When we have two little circulators or any pump in series, for example, a two-pump flow center, pressurized flow center, one pushes, one pulls. On a non-pressurized flow center, they're top and bottom, so they both push the same direction. But in any case, with two pumps, we double the head at the same flow rate. When we have two pumps in parallel, we double the flow rate, but we maintain the same head. And that's where the difficulty comes in. When we have a parallel pumping application, even though we have the capability of doubling the flow, that almost never happens because as the flow increases, so does the pressure drop. So we put three pumps in parallel, triple the flow rate, and so on. So in this case, we actually had two pump flow centers in parallel with a one pump flow center. And that's when all three heat pumps are running. All right, so this chart summarizes what's happening. We cannot get enough flow on our 3-ton with our rule of thumb. Same thing on the 5-ton with our rule of thumb. We can upsize. We can get it with the two-pump flow center on this particular application. So we end up with three pump. Let me start over. We end up with three two-pump flow centers. Tongue twister this morning. In order to achieve our flow rates. So now we have two 26-116 pumps on each heat pump, even on the 3-ton heat pump. So even though it only needs 9 gallons a minute, and it can certainly attain that flow when only the heat pump's running, the problem is when all three heat pumps are running, that's where the challenge is. And so when all three heat pumps are running, we're using about 1,400 watts for those pumps. And when the 3-ton unit's running by itself, it's using about 470 watts. So that's quite a bit more than what we would have with a single unit, single flow center, single loop. That's where the challenge comes in with parallel pumping. All right, so we can use it for up to 5 units. In this case, we had 3 heat pumps. We just have to be very careful with parallel pumping. That's really the issue. Up to 3 heat pumps is typically okay. Up to about 10 tons is okay, but it's certainly not the most efficient way to go. Parallel pumping with variable speed pumps, is another option, but again, it challenges that parallel system. So it's not bad, but we have to use it with caution. All right. So then our central system is another way to go when we have multiple units. In this case, it shows 5 heat pumps, but we're talking about 3+ in this webinar. So, with the costs of variable speed pumping coming down, it makes a lot more sense to consider this. It's certainly much more efficient. And in a variable speed central pumping application, this block that's labeled VFD, that stands for variable frequency drive. In a lot of cases, in fact, with most of the Geo-Flo products, that's actually built into the pump. We use an ECM motor in a variable speed pump in most cases. So in fact, it acts like a VFD, but it's really an ECM motor. The pressure drop is this PD block. Pressure differential. So when this pump is running, it's maintaining constant pressure, and it's based upon these motorized ball valves right here. So as each heat pump turns on, it opens the valve that changes the pressure in the system, and so the variable speed pump speeds up or slows down. And what that allows us to do is only use the amount of flow needed based upon how many heat pumps are running. That's why it's a little bit more efficient. All right, so it's pretty easy to control. There really isn't any wiring from the pump, other than a start-stop function. But as far as controlling flow rate, it's simply based on pressure differential. So as the heat pumps are running, the valves are opening. And if redundancy is an issue, the newer pumps like the Grundfos Magna 3, it can easily be used with a second backup pump. In fact, they talk wirelessly. So if one pump fails, the other one takes over automatically. The watts are much less than constant speed pumps, and it's very scalable. So we can use this same approach with 3 units, 5 units, 20 units, doesn't really matter. It's a lot easier to handle loop pressurization with expansion tanks, air separators, what have you. And we can also step down the piping as we go deeper into the system, and we start having larger piping and then smaller as we get to the other heat pumps. All right, so this is an example with the exact same heat pump equipment we had on the previous distributed example. We have 12 tons, a 3, 4, and 5 ton unit. Again, they're in the same mechanical room, same ground loop, but this time instead of using a flow center for each heat pump, we're using the NP Multi, which uses a Grundfos Magna 3 40-180, and it's controlling flow based upon the zone valves or the motorized ball valves opening and closing. Our pressure drop was 43.6 foot of head at 36 gallons a minute. If we wanted to, as I mentioned, we can add the second pump as a backup. All right, so this is a picture of the NP Multi. This is our Magna 3 variable speed pump, and these are the zone valves or motorized ball valves. Each heat pump has a motorized ball valve. This picture shows a 5-circuit NP Multi. In our example, we just need 3 circuits, so you wouldn't actually see these other 2 circuits in this example. This has a tank, and the tank acts as our expansion tank and our air and dirt separator. And so it's a easy way to pipe a system with multiple heat pumps. All right, so let's take a look at the results then. Remember, we had 1400 watts if all 3 flow centers were running previously. Now, if all the heat pumps are running, in other words, all the zone valves are open, we're using 546 watts. That's when the pump is maxed out. If only one 3-ton heat pump is running, we're using about 26 watts. So that's a drastic difference. Before we had 470 watts. This payback is going to be pretty quick. If we had one 4-ton unit running, it'd probably be around 35 watts or 40. If the 5-ton unit was running, it may be around 60, 70 watts. So it'll be some combination between 27 and 546 watts. And what that does for you is drastically improve the system efficiency. So if we're looking at heat pump COP or EER, that's just the heat pump. The AHRI efficiencies include pump watts, but they're based upon the pressure drop of the heat exchanger. So a 4-ton heat pump may include 70 to 90 watts, depending upon the heat pump pressure drop that's included in the AHRI efficiency. So you just can't get there with constant speed flow centers. If you're using variable speed, you can see from this one example here, we can get very close to AHRI efficiencies. And so now the customer is actually getting what they paid for, and it's a better system. If we need a backup pump, you can see here this example shows 2 pumps in parallel. So they include the check valves installed at the factory, and they talk wirelessly. So if one pump fails, the other one takes over automatically. Also, they can be run in cascade mode, so they both ramp up and ramp down. So a lot of different options there. End result is we average about 214 watts annually versus 940 with flow centers. So a pretty big difference in operating costs. All right, so let's take a look at some guidelines, because it does get a lot more difficult when we look at 3 or more heat pumps. A single heat pump, as I mentioned, we can certainly use 1 flow center, 1 loop, 1 heat pump, not a big deal there. 3 speed pumps are a little bit better because we can dial in the flow for that heat pump. And the best case is the variable speed flow center, because now with a 2-stage heat pump especially, we can dial in the flow, and as we run at lower flow rates, we're using less watts. A 2-stage heat pump runs typically about 80% of the time on part load. So 80% of the year, we're able to use much less watts. And that's why the variable speed flow centers have become very important, very, very popular in the market. So then when we get to 2 heat pumps, and we'll consider 2-stage heat pumps in this example, we could share 1 flow center. We talked about the challenges there. It's not a bad way to go, but it's not quite as efficient. We could also have a flow center for each heat pump. If it's pressurized, that's not a problem. If it's non-pressurized, we can't do that. It is a little more efficient than 1 flow center for 2 heat pumps, but again, it's going to add cost. And then the best case scenario is if we have 2 heat pumps, each heat pump has its own loop and variable speed flow center. Now, another option here, I didn't have room for it in this particular chart, but we have the dual circuit flow center, and that's almost as good as a loop and a flow center for each heat pump. Very, very close, and it's certainly easier to install, and it's a great way to go. So the NP Multi would be a great consideration for this application. When we get into 3 or more heat pumps, you could certainly have a flow center for each heat pump. We just have to be careful if we're using these on a common loop because of what we looked at earlier with that parallel operation, higher watts, of course, and we also have to typically upsize the pumps because of that parallel operation. Now we could have a heat pump for each, a heat pump with its own flow center is fine on each loop. So a heat pump, flow center, ground loop for each heat pump, that's a good way to go. But it does have a lot of building penetration. So now we might have on a 3-unit application, we may have 3 sets of supply and return lines, and those have to be, we have to get those into the building. And then the best case would be what we talked about earlier with a central system, which is the NP multi, and that gives us the ability to have a variable speed pump and zone valves, and that's on the next slide showing our 3+ heat pump application table. All right, so now when we get into the 3+ systems, it becomes really a function of system pressure drop. The very efficient ECM circulators like the Magna 3 that I had in the picture earlier with the NP multi, there is a limitation, and that limitation is about 50 foot of head. In differential pressure mode, it may be closer to 45 foot, depending upon which pump we select. So that's our first thing to look at. If we have around 40 to 45 foot of head, it's pretty easy to justify a variable speed central pump. And we have, of course, the option for a backup if we need redundancy. So that's certainly something to look at. We could look at a primary, secondary. These last 3 columns, by the way, are more of commercial nature. And later on, when we do some larger job webinars, larger application webinars, we'll look at primary, secondary, and one-pipe systems and all that kind of thing. So I'm not going to get into a lot of detail for our purposes today. Now, if the head is above 45 foot of head, that does put us beyond the capability of those very high-efficiency ECM circulators like the Magna 3. We can certainly use 2 of those in series, but that adds quite a lot of cost. So in that case, maybe we need to break that up into a different type of application. And so that's something we can talk about later on in primary, secondary type applications. We can certainly use it. It's not our preferred way to go. When we get into 10+ heat pumps, now that changes things quite a bit, and that's where we're into the larger system applications. So we are right at about our half an hour stopping point. I'm going to stop here for questions, and I certainly appreciate everybody's time. So the first question was, how long is this webinar? Well, that's I guess I should have looked at that one earlier, but we're finished up now, so that we answered that question. All right, the next question here, when will the slides be available to review? And those are going to be posted on the Enertech website, and you can certainly contact Enertech Inside Sales, and they'll be able to get those to you. The best way, though, is to review this presentation online, because we're recording it, and so that way you have the dialogue to go along with the slideshow. Okay. Next question. Presentation's good, but I'd like to review the slides. I think we already answered that one. Okay. And I'll hold on here for some other questions. Appreciate your attention and your questions so far. Okay, here's the next question. It says, how is the pressure drop set to control the VFD pump? Let me back up a couple slides here, and I'll show you what that system looks like. All right, so when we're controlling the pump, this Magna 3 has a color screen on it. It's a little hard to see in this slide, but then you have an OK button, an arrow up and down, and several other buttons on the screen. So when this ships from Geo-Flo, it's set up for a typical geothermal application. So it's set up for constant pressure mode, and it's set up for the maximum pressure in foot of head. So when you set this system up, you're going to take all of these zone valves and open them to their full position, and then energize the pump. and that will then allow you to balance the system. So with all of these zone valves open, you'll go around to each of the heat pumps, you'll check pressure drop across the heat exchanger, and that will tell you how well balanced the system is. So let's say we have 5 heat pumps and a variety of different sizes. We may have to adjust the flow a little bit. If you have enough flow, in fact, if you have, typically you're going to have more than you need at that point. Now we go to the front of this pump panel and we start reducing the max head. Go back and check heat pump flow rates. If we still have more flow than we need, we reduce the head a little bit more. The more you can reduce this, the lower the energy costs are, but also the quieter the pump. It's very, very quiet because it's a wet rotocirculator, just like the small little flow center pumps. But still, if it's running at 100%, it's going to be noisier than if it's running at even 90%. It's amazing how quiet this thing is, just slightly below max. So then once we have everything dialed in, we have proper flow rate for each of these heat pumps, and we have our max head setting on the pump. That's it. You're done. So there's really very little setup. Now the pump's capable of doing delta T. It's capable of a lot of different modes, but in this particular application, we're going to be looking at differential pressure. So that's a typical way we would set that up. Good question. All right, let's take a look at the next question. Is there any cost of equipment analysis available? There's nothing really as far as a white paper or anything like that, but based upon our experience as far as cost goes, it seems to be in that 3 to 4 heat pump range where it makes sense to start looking at central pumping. And by that I mean, if you look at the cost of multiple flow centers, if you're looking at 3 variable speed flow centers, or 4, there's a little bit of, depends on your selection and your pressure drop and so forth, but 3 or 4 flow centers is similar to the cost of a system like this. So that's where we start to turn the corner and look at more central applications, and that's something Enertech can certainly help you with. They have access to all of the Geo-Flo product, and do a great job of helping contractors with sizing and selecting equipment and that kind of thing. So it's a matter of looking at pressure drop, and if you want to go online to the Geo-Flo calculators, it's www.geo-flo.com, and there's a design calculators link that you click on. They're free calculators, but that allows you to do a pressure drop calculation for 1 heat pump, 2 heat pump, multiple heat pumps, including this NP multi that's on the screen here. And then once you know what you need as far as pumping goes, then it's just a matter of getting pricing for multiple flow centers versus a central system like this. So changes on every job, but again, generally in that 3 to 4 heat pump range, that's where it makes sense to start looking at systems like this. Okay, let me take a look at the next question here. Appreciate everybody's questions. All right, installation cost of one scenario versus the other. I think we addressed that in the previous question. So I'll hold off here a little bit for additional questions. Okay, here's another question that just came in. What are the zone valve choices for this product? And the picture here shows the Taco GeoSentry, which is a nice choice from a cost effectiveness standpoint. This is one choice, and it's good up to about 4 tons of equipment. It has a CV of 8.9, so much above 12 gallons a minute. Our pressure drop can get a little bit high. So this is also available with the Belimo valve that has a CV of 30, and that'll take us easily up into the 6, 7, 8 ton range. These are 1-inch connections, so you wouldn't really want to go much above 7 or 8 tons on an individual circuit, just because of pressure drop. In fact, when we select this product, we want to go with the largest heat pump first, so that most of the flow gets diverted to the first one and then the next one and so on. Okay, good questions. Let's see what else we have here. Okay, let's see. This one's just a thank you. Well, I appreciate it. Thank you very much as well. Okay, well, I think we'll go ahead and wrap up. The questions were great. I certainly appreciate the time. Enertech is a great resource for you. Make sure you use their resources and support on these applications. As Kyle mentioned earlier, We'll get into more detail on this specific product that you see on the screen in the other two webinars. This webinar was really more just to give you an overview of some of the challenges and solutions. But with technology that's changed, and in fact the pricing that's come down on variable speed pumping, we have a lot more choices than we did even just a few years ago. So thank you very much. Hope you have a good day, and let us know if we can be of any help.